Swayam Prabha. Digital India. Educated India.
Hello everyone. In this lecture, we will talk about built environment and energy consumption. So, if you see this table, it talks about the share of the built environment and their respective resource uses. So, the resource uses different resources such as energy, raw materials, water, land. They are actually bifurcated. Like how much the built environment, the buildings are consuming actually this. So, the first table actually talks about, and it carries like a 40% of the energy use. So, as I have stated earlier, the buildings are the single largest actually consumer of the total world energy, and they consume approximately 40% of the total world energy, even more than the industrial sector. Okay, even more than any other sector. So these are the largest consumers. So if there is a saving of any fraction of also a percentage saving, so the overall resultant saving in terms of a volume will be tremendous. And the second actually is the raw materials used by buildings. Okay, so that is resting at around 30%. Okay, water usage around 20%, and land uses around 10%. So we can see the total land whatever is available for our uses these days. So this is occupied by buildings alone by the percentage of 10%. And the water, whatever water we are consuming actually these days, the buildings take total of around 20% of that. And raw materials, what we consume, what buildings consume, okay, for construction material, for their operations, for the maintenance, so all of that put together, it consumes around 30% of the raw materials uses. Okay, so which is huge. So in terms of a resource and energy consumption, the buildings are one of the largest consumers in the all of the sectors actually combined. And the second actually table talks about the share of the built environment in pollution emission. So here if you see the CO2 emissions also happen which are caused by the buildings is at the rate of a 40%, which is very huge. And the second one a solid waste generation by buildings stands at the rate of 30%, and water effluents 20%. Okay, so these are also the byproducts of any building, such as emissions, such as waste generation, such as effluents and other toxic materials and exhaust, okay, coming out of the buildings as a resultant of several processes, okay, such as air conditioning. And there are several actually compound based actually finishing materials which are being used these days, volatile organic compounds, VOCs, we used in the finishing materials such as lacquer and paints, and several other treated wood materials. There are several types of adhesives and resins are also being used. There are several types of the treatment materials used in the flooring system, such as epoxy. So all of these have actually a huge environmental impact. So as a emission, if you see, buildings are also responsible for a very high emissions in terms of toxic materials and gases. So two big areas for the potential of a saving, if you see. So it is very evident from the previous slide, buildings are the largest consumer of resources and energy, and they are the largest emitters also. So in turn, if you see from the opportunity perspective, as a designer, as an architect, and as an engineer, okay, I'm sure you will see there is a huge scope also, there is a huge potential also for the saving from on all of these actually factors. So if you see buildings are standing compared to other industrial sectors, for example industry and transportation, buildings are coming at the top. Okay, so as a resultant, we can see there is a huge scope of potential for improvement also in terms of optimizing on the energy usage, energy consumption, on the parameters of sustainable resourcing of the materials and the raw materials which are required for the buildings, for the built environment actually these days. And if you see the numbers given on the left side of this actually illustration, so it talks about the building sector accounts for almost half of the energy consumption in the United States. Okay, so this is just an example from one country. Well, United States of America is one of the advanced countries, and there the contribution of energy to serving actually buildings alone is by almost 50%. which is tremendous. Okay. The second one, buildings account for over 70% of total US electricity consumption and are responsible for over 40% of CO2 emissions. Okay, so the total electricity consumed, okay, of that actually 70% is taken by the buildings alone over here. Okay. And the last one, industry accounts for 32% of total US energy account consumption. So the industry, even though like industries are like a very critical and important for the actually manufacturing and other processing of like a stuff, but industry is still lagging behind the buildings. That means buildings have actually far outrun the resource consumption and the energy consumption. So in itself, it is evident like there is a huge scope in terms of like improvement in on the like resource consumption and energy in the buildings. So here if you see what could be the benefits, okay, for the buildings and the buildings owners and the occupants and the civic bodies and the political administrative agencies to for the improvement of such efforts. Okay, so it is given at the 3 scale, one individual building scale, and at second at the a district scale, like an urban scale, and the third one is at the city scale. So what could be the benefits if you see if we work for the building efficiency, okay, and on-site actually power generation, if we work for the storage of that on-site generated power, okay, for the consumption on the later times. Okay, so what could be the benefits? So the common ones are listed over here. The most efficient actually resource use, manage resources consumed, okay, reduce costs actually of for energy and other resources, reduced resource use of course, and reduced demand on the electricity grid, because taking actually power from electricity grid actually exerts a lot of impact and pressure on the overall system, because that power has to be generated somewhere and transported to your place. So in the transportation itself, there is a huge a percentage of that power, it gets lost. It depends on the a distance, but yes, there is always a certain percentage of that power that which gets lost in the transmission. So by generating power on site, we can reduce our dependence on the grid. And secondly, we can reduce we can almost nullify the losses happening in the transmission of the power from one place to another, and we can go independent of the grid to have to generate our own electricity, and reduce stormwater infrastructure needs. So in such a disastrous situations of disaster of a flooding, and there could be benefits in such scenarios also. And what can happen at the district level, at the urban scale level? So if we regulate the heating and cooling of these buildings, if you regulate the transportation efficiency in that over area, encouraging a pedestrian and the movement on cycles, okay, if we minimize personal vehicles, if we promote a public transport, okay, and if we actually devise a microgrids. So microgrids are the arrangements, okay, which serve actually for a smaller area, very a focused area. For example, maybe one neighborhood. Okay, so there could be actually power generation plants such as a solar photovoltaic actually cell based, or there could be a wind farms. Okay, there could be a tidal actually energy harvesting farms. Okay, so these smaller units can provide actually electricity for smaller areas. For example, maybe an area of maybe 200 acres, 500 acres, or even maybe 1,000 acres. So this actually policy is these days being promoted in the government institutions such as IITs and IIMs to generate their own actually electricity on campus. So these actually campuses are being facilitated with the power generation plants. So at least a significant percentage of their power requirement they are meeting through actually these needs. Okay, so this is a novel initiative actually taken from the governmental agencies to improve actually and implement these microgrids. So what could be the benefits of such scenario? As you can see over here, on-site resource management, okay, production and storage, so that the centralized power plant units, the dependence on such units will actually reduce. So we can have actually distributed actually economic model, which we will discuss more in detail in the length chapter. Okay, so those kind of actually distributed economic models can be implemented on a site to site. There could be a local aggregation of demand, how much a power is required on a particular location. so that can be assessed properly and more accurately than actually covering a bigger area. So those kind of like a accuracy, like a accurate forecast also can be actually can be created to generate power and meet that demand. Improve resource distribution and improve performance and resilience. So of course, since this unit is going to work at the local level, so the resource distribution, the resource actually requirement for like this unit can be taken like locally, without like a interference from from a farther, like a far away places. So this will actually improve the performance at the local level and the resilience of that actually locality. So resilience is very important for like a survival in any like a eventuality kind of like a conditions. So this is very important, because if this works properly, then the place in itself will become actually independent of the other places. So if something goes wrong, for example, like in this globalized economy, if one country faces a difficult situation in this economic like a system, so the all other countries also gets affected. So that's actually repercussion of like a such a such a system where every like institution becomes so dependent on the other that if something goes wrong with one, everyone gets collapsed. Okay, so we should actually go independent of like a such like a system. We should develop that resilience. So this is the reason actually resilience become very important in today's time, to actually generate that resilience at the local level. And what will happen at the city scale? If you see this illustration, it talks about improving on the like a transportation from personalized to public. Okay, improving on like a cycling, improving on like a battery powered like vehicles, and then the compact development. So the compact developments, by that means like the development in a very like a efficient manner. So the more number of actually output can be actually created in a smaller areas, to optimize on the space, to optimize on the land. Okay, and then the next the feature which we are talking at the city level is of the mixed use of the buildings. So the buildings can be made of the mixed use, like they can be used for like a extended hours, extended duration of the day or night. Okay, so that the resource which is like invested so much in that building can be utilized for like a more amount of time. For example, any school, if it is running like their classes, so what is happening in that building or a space after the school hours? Well, that building is closed for those times. So is there any way to optimize, to make use of that space for like a multi-purpose like activities? So why not such initiatives can be taken care of? Okay, so what could be the benefits in such like scenarios? So avoiding like a increased like a infrastructure costs. Okay, avoiding like a health cost, because if people are like a fit enough, if people are taking care of their own like a individual like a health, the health of their family, if they are taking like a public transportation, if they are cycling, if they are walking, jogging. Okay, so obviously it will result into an improved like health condition, which will in turn like exert lesser impact, which will demand like a lesser actually cost investment from the like health sector. Okay, it will reduce the need of like a several kind of like a services which are not required that much. Okay, which are not critical in nature, so at least we can avoid those type of like a services. And of course the lower energy demand and related emissions from public infrastructure. So since the public like a infrastructure, okay, will have like a better actually capacity to serve the people, so the per person actually emission will get reduced significantly. Okay, next, if you see over here, how to design and build an energy efficient building. Well, this slide we have discussed earlier, but I have kept it here again to remind you like how we can go in the approach. So the first approach actually talks about reducing the demand. The second one talks about actually using the renewable resources and avoiding actually non-renewable resources. And the third one, even if we need to like use such resources, we must use them with much efficiency as much as possible. So on the left hand side you can see what are the strategies for employing like a such in the like a designs of our like buildings and other products. So using the concept of like a bioclimatic architecture, so the shape, orientation of the building, solar protections, passive solar systems can be installed, okay, in the building to take the maximum advantage of the solar the direction, the solar availability of like a sun, and the actually prevailing winds and all of these things, and even the topological actually characteristic and topography. The second, high performing building envelope. Thorough insulation should be there so that to minimize the actually losses. High performing glazing and windows, air sealed construction, avoidance of thermal breezes. The third one, high performance controlled ventilation, mechanical insulation, heat recovery. So heat recovery is also one of the options which several projects are using these days, where they are actually recovering heat from services. If there is a heating actually mechanism installed in a building, or if there is a cooling mechanism installed in that building, so that the energy which was invested for like a cooling that particular air should be harvested back as much as possible if there is any fresh air change or any such activity. So the cool air can be diverted if it is exiting that building, so that cool air can be diverted to other ancillary activities. So that is the actually purpose with this, to maximize the uses of the energy invested in any component of the building. So how this bioclimatic we can take use of this actually. So I'll quickly explain this topic over here. It takes account of the climate and environmental conditions to help achieve thermal and visual comfort inside. So bioclimatic design actually takes into account the local climate to make the best possible use of solar energy and other environmental sources rather than working against them. So bioclimatic design includes the following principles. So there are two principles I'll explain briefly. The shape of the building has to be compact to reduce the surface in contact with the exterior of the building, the surrounding of the building. The building and especially its openings are given an appropriate orientation, preferably towards the south. Okay, interior spaces are laid out according to their heating requirements, though actually these directions will vary depending upon the location of that site and that the building, okay, across the planet. So that from the northern hemisphere to the southern hemisphere, the orientations may completely go opposite. So we have to actually take care of such calculations depending upon the actually location on the globe. The second one, appropriate techniques are applied to the external envelope and its openings to protect the building from solar heat in winter as well as in the summer. Passive solar systems collect actually solar radiation, acting as free heating and lighting systems. The building is protected from the summer sun primarily by shading, but also by appropriate treatment of the building envelope. The use of reflective color and surfaces. For example, if we do not want much heat gain from the sun in the summer months, so we should use actually reflective materials to reflect back the heat quotient of the sun's rays. Okay, and in winter, if we want that heat to come inside, then maybe we can use suggestive materials which allow actually heat retention in the building. Similarly, in the thermal insulation, so thermal insulation, it is a low cost, widely available, proven technology that begins actually saving energy and money. It reduces actually emissions because it helps actually the system in an indirect way. It's minimizing, it's reducing the actually losses which are happening in the process of actually heating or cooling. Okay, so this insulation is very important to improve the overall efficiency, because a major portion of around energy gets lost just because of weaker actually insulations. So well, insulated insulation in the building ensures energy and efficiency in the every part of the building. So how this can be done? You see, there are 2 points over here. An exterior wall is well insulated when its thermal resistance, the R value, is high, meaning the heat losses through it are small, reduced U value. Insulation is a key component of the wall to achieve a high R value for the complete wall. The thermal resistance R of the installed insulation products has to be as high as possible. So you see every material has a certain thermal resistance. For example, brick, okay, we generally use a concrete, we use a wooden panels, we use the stone materials, okay, we use a timber, we use these days we are using aluminum, we are using steel, mild steel, we are using glass. So every these materials, they have some R values, okay, which is a thermal resistance. So how appropriately the property of this thermal resistance can be applied to reduce the heat intake in the summer months and to increase the heat intake in the winter months, okay, which is fitting for a northern hemisphere, can be actually made use of. So this is the actually strategy based on the property of the material we can actually apply. The second one talks about to limit the thickness of the insulation within acceptable dimensions. There are some companies like Saint Gobain, Okay, so they have actually launched some actually glass materials which have actually the lower actually R values as compared to the like a conventional like a glasses. Okay, so which helps in turn like a minimizing the actually heat load. So these glasses actually are called like a reflective glasses. So they actually reduce the heat component in the sunlight. Okay, and as a resultant, the air conditioning load on any like a space is like minimized significantly. The next one I would like to talk about here is the air tightness. So this also like with the like a convection. Okay, there may be the actually loss of the energy from like inside to outside or from outside to inside. So how with this air tightness also we can ensure the like the maximum efficiency on the like energy systems. So this is also one of the a part of the like overall like a strategy to actually apply this air tightness, to use this air tightness to minimize the actually losses by convection. So this actually reduces or minimizes or breaks the actually air leakages, okay, happening anywhere in our like ducts or anywhere from the interior spaces to the outside. Okay, so it checks actually the gaps, cracks in the building, okay, or the construction or the interior spaces, or even in the fall ceiling, in the windows, in the doors, to maximize the actually effect of the invested energy. So how this can be done? The details that are vital to achieving good air tightness need to be identified at the early design stage. The next and equally important step is to ensure these details are carried over into the construction phase. Careful attention must be paid to sealing gaps and ensuring the continuity of the air barrier. It is far simpler to design and build an airtight construction than to carry out remedial measures, okay, afterwards, because the remedial measures actually may not actually work properly. So it is always recommended to go for like a such details at the time of the design itself. The second one talks about from a particular company like a Saint Gobain. So there is one actually model they have launched. Iceover has developed system with the innovative accessories that allow appropriate insulation of the insulation while guaranteeing excellent air tightness and allowing like a proper moisture management. So see like how different companies, the private companies, are also coming to the rescue to the of the cause of the like a ecological like a balance. So saving energy, saving resources must become like a motto of each and every like a organization, whether it is government or private or every like a manufacturing unit, to serve the overall purpose of like a bringing like a energy efficiency and efficiency overall in the like resource consumption. The next one it talks about here is the ventilation. So the how the ventilation can be controlled, okay, for like a bringing fresh air, for like a cooling it, for like bringing it to the desired temperature. So if you do not insulate properly and ventilate too little, you can risk warm humid air condensation on the cool poorly insulated surfaces, like we observe it generally in the like a humid months. Okay, sometimes we observe like a condensation and water droplets forming. So this that's because of the better bad actually insulation processes which were carried out at the time of the fabrication or the manufacturing of that actually unit. So we have to check such actually things, which actually in turn will further give rise to the the growth of like a mold and fungi in the interior spaces, and which can further actually cause damages to the health of the occupants. The next one it talks about a controlled ventilation strategy will satisfy the fresh air requirements of an airtight building. Air infiltration or opening of the window cannot be considered an acceptable alternative to the design ventilation. Okay, the last one, as the saying goes, build tight, ventilate right. So this is very important that the whole system of the building should be actually airtight completely, so that the intended actually resource consumption and the energy consumptions can be achieved. So it is very important to take care of these smaller details at the time of the construction only, because it will be very difficult to rectify them once the construction is over. So if you see like the overall what is the like a thermal energy like a consumption pattern. So these red lines are represented by the traditional optimization thermal energy consumption. The blue one talks about predicted thermal energy consumption, and the green one is the building information modeling optimization thermal energy consumption. So what happens in the like a traditional like optimization method, what happens when we like predicted, and what happens when we take help of like a BIM model actually consumption pattern. So these are latest tools and softwares and mechanisms such as like a building information modeling they have added quite a lot to the energy efficiency and managing any enterprise, managing any building or the built environment efficiently for resource consumption, for the operational resource consumption, for such as energy. So energy is one of the actually components which a building uses as long as it is functional. So you can see this red line, which is like a traditional optimization thermal energy consumption, which is always in the higher scales. Okay. So if you see in the observation was done over a range of 40 days, over 40 days. So how it has actually fared in these actually in the traditional way, and how this can be taken care of by going for a predictive models, and how BIM has actually finally resulted with the help of all of these methods. Okay, so by employing actually such methods such as insulation and air tightening and all that, so how this has resulted as effectively, so it's quite less than what is being used in the traditional systems. So we can see over here the effects which a BIM rated BIM model actually structure can provide. Here this chart, I think we are coming towards the end of this lecture. So this chart actually provides the building energy end use consumption in cold and a moderate or warm climates. So this is from year 2012. So the first actually circle talks about around 45% for a heating spaces. So the energy used in the cold climate countries. So on the right side it talks about the energy used in the warm countries. So the colder countries, 45% of the energy is used in heating their spaces, which is the largest actually component among all of these. The next one is the water heating, because these places the water gets frozen, it becomes ice, and the building services actually cannot run. The water supply and the sanitation cannot function. So in these actually places, there are provisions to keep heating the water on the regular basis so that it doesn't freezes in the pipes. So these two are actually taking almost a 55 to 60% of the total energy requirement of a building. And on contrary to that, if you see on the right side, okay, so in this one when we see, so here the cooling becomes very important. Okay, so traditionally if you see in these buildings which are in the warmer countries, so the space cooling is requires only 3%. So compared to the counterparts from the colder countries, so this is very little. Okay, but on contrary, we have some other observations 38% of the energy is used in the cooking, which is the highest in these countries, and 30% energy is used for a water heating. So water heating for several purposes, for kitchen use, for the bathroom use, and several other. And space heating is required only a 13%. Okay, 11% is required for appliances and other equipment, and 5% is for lighting. So I think lighting remains more or less, I think, closer to each other in the both of the actually context, from 5% to 7%. Okay, but space cooling also relatively is lower in both of these, from 3% to 5%. Okay, but this heating actually is changing quite a much, and in this scenario on the right hand, on the warmer countries, we are seeing this the actually range of this cooking requirements which are very high, up to a 38%. So how these most efficient actually buildings can be actually achieved? So there are some action points which are actually prepared from this World Resources Institute. So we will discuss one by one. So the stakeholders are listed on the left side. So this talks about the national and provincial governments, because they frame the policies. They are actually the topmost bodies to create rules and regulation and laws. And local governments, which enforce actually local laws and optimize actually resources. And energy utilities, civic society actually organizations and bodies such as municipal organizations, developers and self-help builders. Okay, design and construction professional like you and me, suppliers and manufacturers, financial service providers and investors, building owners and managers, and of course the last one is very important, building occupants, because they are the ones, they are the people who are going to use these buildings over a long period of time. So during the operation stage, their actually environment and interest and their actually intention matters the most. So what could be the action points over here? So to prepare actually codes and standards, fix some targets for the resource optimization, for the energy consumption and all. The third one, information and certification, to go for actually such information dissemination actually systems where these targets can be actually achieved, and giving incentive and financial help to these stakeholders. Okay, for example, manufacturers, if they are creating a compliant products, okay, so their production must be incentivizes. The power generation, if a site, if a building is going for a net zero energy kind of concept, then these enterprises or these buildings also should be incentivizes to promote independent a power generation actually system with the help of a microgrid and all. The action 5 suggests a government leadership by example. So the government, the regulating bodies must first produce actually such examples by actually modifying or by having such efficient buildings of their own use. Like as we saw in the Indira Paryana Bhavan, so Ministry of Renewable Resources actually constructed the India's first net zero energy building in New Delhi, which is situated in the Lodi colony area. So that building actually generated its own power, rather it generated surplus power and it's supplied to the local grid over there. So that is one example actually set by the government institution itself, which is quite actually a healthy example for the others to follow. The sixth one talks about engaging owners, managers and occupants. So this actually awareness of these stakeholders is very important, because generally they are the ones who are going to use these buildings. They actually maintain these buildings, they take care of the upkeepment. So their awareness and information actually is very important, so that they can take care of the loopholes. The second one, engaging technical and financial service providers, and the last one, working with the utilities. So by this actually the help of these strategic actually action points, we can see over here, we can work for optimization of the buildings, for making them a most energy efficient buildings. Okay, so this is actually the bridge which is proposed over here. So from stakeholders as and to the result of energy efficient building, this is the way we can actually lead for actually this desired actually situation. Well, some barriers are there, but they can be actually taken care of. Barriers such as a market. So market, does the market have such supply, such materials in abundance? Are there a financial services available, the financing available for erecting actually such efforts? Okay, are there technical advantage and merits available, technical knowledge available to meet actually these targets? Okay, is there awareness in the stakeholders? Are they aware of the possible efforts which can bring some results to this project? Okay, and are there institutions to support actually such activities? With this, I would like to bring the end to this discussion. Thank you, everyone.